We're in a critical position here in Earth history. You know, the greenhouse effect is a real thing. It's happening. We can see the Earth is changing. The interest in climate has moved NASA to two arenas. One in the Arctic, there's a huge interest in ice and how ice is behaving, whether it's melting and how the Arctic is warming. The other issue of importance in the greenhouse effect is the tropics.
This is where humongous amounts of energy get released in convective cloud systems by condensing water vapor, and this is where the water vapor gets into the atmosphere in the first place.
We're seeing global pollution moving from one hemisphere to the other. So we really need to understand how clouds and water vapor respond to this forcing from the greenhouse gases that people are putting in the atmosphere.
TC4, the Tropical Composition Cloud and Climate Coupling Experiment, is providing us with a unique opportunity to use all of NASA's observational assets to study the Earth's climate system. We're here in Costa Rica because, one, it has the logistical capabilities for basing the unique aircraft that we utilize, but secondly, it gives us access to an atmospheric region which is called the Tropical Tropopause Transition Layer. Basically, that's a region in the Earth's tropics at about 10 to 12 kilometers, where we find a lot of these strong convective systems, these storm systems. So our ability to understand the processes that occur in this transition layer is inherent to global models of future climate.
TC4 involves several hundred people here operating 3 NASA aircraft, the DC-8, which is like a converted airliner into a laboratory, the ER-2, which can fly in the stratosphere and is a surrogate satellite, and the WB-57, which can fly through the tops of deep convection and tell us really what's right in the clouds. So we're trying to see it from both ends and in the middle.
The type of instrumentation that we have here is almost equivalent to taking an MRI of the atmosphere. It's enabling us to probe it in great depths, looking at all the individual organs, seeing how they operate.
The ER-2 is a platform. It's an aircraft that has a bunch of what we call remote sensing measurements on it. So the ER-2 is flying very high, up around 68,000 feet, twice as high as your normal commercial airliner. Well, we can put this plane wherever we want at the proper time to look at a particular cloud system. So we can put a huge collection of instruments right above a thunderstorm or a cloud that we really want to look at.
The DC-8 is a really great research aircraft for NASA. The passengers are really the experimenters, and their instruments are with their instruments all the time. And we can watch the data as we're going along. And so if something interesting happens, like we fly through a plume of pollution, we can turn around and go back to it again and make more measurements. It has remote sensing and in situ. So the in situ instruments, like the ones along the wings and the ones sticking out the windows, are to tell us what's going on at the level it's flying. The remote sensors are probing upward and downward to tell us what's going on below and above us.
So far, we got quite a few nice cases where we had the clouds between 2 aircraft and measuring with the same instrument around it. And we're going to see what the data look like, but these are really quite nice cases that we haven't had before and where we can study the effects of clouds.
We've had beautiful flights flying back and forth across these cloud systems as they change. So we're getting some great data looking at the evolution of these cloud systems that are down at the equator.
If he went.
This is incredibly exciting to see this revolution that's taken place and the ability to plan and control these experiments in real time. So the amount of data that one can get that way is just astronomically greater than what one could get a decade ago when you couldn't control the airplanes.
We are making a substantial percentage difference in the amount of information that's available to scientists on the tropics. And not only that, is the information now is being collected with sensors that are 30 years more mature than when they were originally.
But this is the first time there's been a large field program of any type that's looking specifically at the upper atmosphere and how convection interacts with the stratosphere and with water in the upper atmosphere. And we hope it won't be the last such mission. This tropics is half of the world, and it's a very little studied area, so there'll probably be follow-on missions to this one that give us more insight.